From the surface chemistry, you have two experiments. The first one is preparation of ferrous ammonium sulfate. What is ferrous ammonium sulfate? We are familiar with this. This one is mohrsalt, and it is also known as a double salt because it is a mixture of ferrous sulfate and ammonium sulfate. Ferrous sulfate and ammonium sulfate combine to give mohrsalt, that is our ferrous ammonium sulfate. So we'll see how to prepare this ferrous ammonium sulfate and what are the things required for this and what type of reaction occur in the preparation of ferrous ammonium sulfate. So the theory. It is also known as mohrsalt and it is prepared by dissolving equal molar mixture of ferrous sulfate and ammonium sulfate, and we are adding sulfuric acid to this and we are crystallizing. It is used to ethyl alcohol, and this is the equation for the preparation of ferrous ammonium sulfate. Here we can see it is a combination reaction of ferrous sulfate and ammonium sulfate. This both will combine to give our double salt, that is our mohrsalt. So it is a combination reaction. And the things which are required that is unfamiliar to you, those are beaker. You know what is beaker, and tripod stand. This tripod stand, we are using, it's a stand for the burning purposes. We are using the stand. And funnel stand. This is funnel and this is funnel stand. Watch glass, you are familiar with watch glass rod and all. Then filter paper, we are using this type of filter paper. And china dish. This is a heat resistant equipment for the we are heating this mixture in this. For that we are using this china dish. And the chemicals required are ferrous sulfate. Ferrous sulfate is a green color solid which is in green color, and ammonium sulfate which is in white crystalline compound. Ferrous sulfate is green crystalline compound and ammonium sulfate is white in color. These two mixed together will get mohrsalt, which is a pale green colored compound. We have seen this in our earlier experiments, and we required some ethyl alcohol. This is for the crystallization, and we required some dilute H2SO4. These are the chemicals required for the reaction. The procedure, we can see this in the YouTube URL given your next topic. So the procedure is we have to weigh separately 7 gram of ferrous sulfate. We have to weigh it separately. You know how to weigh. We already done the weighing and all. So take a piece of paper and tie our instrument weighing machine. Then add 7 gram of ferrous sulfate and take that and measure 3.5 gram of ammonium sulfate similarly, and mix this ferrous sulfate and ammonium sulfate in water in a beaker containing dilute sulfuric acid, and so we'll get a turbid solution. By the mixing it won't dissolve completely. The next step is we have to heat to get a clear solution. Then we'll get a clear solution and filter the solution, and if there exist some impurities, we can remove that and we'll get clear solution, clear filtrate. After the filtration we get clear water that will be green in color. Take that and add this to china dish, that white color equipment, and over a sand bath. For that we need a sand bath that you can see in the video, and we'll heat up to the crystallization point reached. And during heating we have to stir it occasionally, and we have to keep the mixture for the slow cooling, because we do not disturb in this time. In order to get a clear crystals, we do not disturb. It will slowly cool and will get crystal type compound, and separate the crystals from that mother the first liquid, and wash the crystals with cold water, and dry the crystals between the using our filter paper. This all you can see in the video. This is the experimental setup, that is in the this is first step. We have to measure the ferrous sulfate and ammonium sulfate separately and add to beaker which contain dilute sulfuric acid, and pour this, and we have to filter it and pour it to a china dish and heat the china dish and separate the crystals, and wash it with water and dry the crystals. These are the procedure. So what are the precautions we have to take while doing this experiment? That is, first step is allow slow cooling and do not disturb the solution during cooling in order to get good quality crystals. If we disturb the mixture while crystallization, we won't get good crystals. If you want to get good crystals, we do not disturb. If we disturb, the crystal structure will vary or some impurities will come. Such things will happen. So we do not disturb the cooling mixture and allow slow cooling. Don't be fast or don't be make mistakes. The next step is next precaution we have to take is during the process of heating the solution. I should be done short time. Otherwise, we know it's contain ferrous. We have to prepare ferrous sulfate. But if we overheating this mixture, we'll get ferrous ions will converted to ferric. So in order to inhibit that process, we do not heat it prolonged. We have to heat it in short time. If we heat, it will get clear solution. When we reach to get the clear solution, stop the heating. Otherwise, the ferrous ions will convert to ferric and we won't get what we have expected. The next precaution we have to take is, so suppose if the solution is yellow instead of green, the experiment should be repeated. Then the entire experiment will be wrong, because if it will get the yellow color while the ferrous will convert to ferric, so we'll get to know that our experiment was wrong. So we have to repeat the experiment once again. So these are the precautions we have to take. And we are adding dilute H2SO4 in this reaction to avoid the hydrolysis process, and these are the procedure, and you can see the video which will help you how to do the experiment. Then the notes and how to write the record and all are given by the notes. You can do that. Okay, thank you.